So coming to the next question, question number 10. So what are elastic collisions? What are elastic collisions? The collisions in which energy, momentum, kinetic energy, momentum and total energy are conserved. Such collisions are called as elastic collisions. Now show that two identical bodies move along a straight line, exchange their velocities after colliding elastically with each other. So in that part you have to show the derivation of elastic collision in one dimension. Okay, because one dimension, why? Because two bodies moving on a straight line, so it says about one dimension. Okay, so exchange their velocities after collision. So we know the formula, you know the derivation. Two bodies of mass m1, m2, initial velocity u1, u2, after collision v1 and v2, and we will use the concept of conservation of momentum. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, and conservation of kinetic energy, half m1 u1 square plus half m2 u1 u2 square is equal to half m1 v1 square plus half m2 v2 square. You will use those two equations and you will reach the final formula for v1. You will get it as m1 plus m2, sorry, m1 minus m2 divided by m1 plus m2 into u1 plus 2 m2 divided by m1 minus m1 plus m2 into u2. So this is the formula you will be getting. Now what you need to prove, after collision they exchange their velocity. Similarly you will get for v2 also. Okay, when they exchange their velocities, what will happen? That is the question. You have to show they are exchanging their velocities. How it happens? When both m1 and m2 are equal. m1 and m2 are equal, this term will go 0. So 2m by m plus m2m, it will become 1. So 2m by 2m. So you will get v1 is equal to u2. That means in order to show this question, that is in order to show that after collision masses exchange their velocity, what you need to consider the case is which case? m1 is equal to m2 is equal to m. You have to derive till here, then you have to apply this condition, then you have to prove v1 is equal to u2 as well as v2 is equal to u1. That is the proof they are asking. Simply if you do this derivation, you will get only half mark. For the assumption, for the specifically what they have asked, you have to do. Okay, then only you will get the full mark for the derivation. Now, the problem part. A truck of mass 1000 kg moves with a speed of 72 km per hour, collides with a stationary truck of same mass. So two trucks mass same. Initially the first truck with 72, the second truck initially at rest, so you do 0. So 72 km per hour you convert to meter per second by multiplying it with 5 by 18. Now you have to find, after collision the trucks stuck together. When they stick together, the total mass will become m1 plus m2. After collision they both stick together, so the mass will be m1 plus m2 after collision. Calculate the common speed after collision. So what you will do? You will do momentum before collision is equal to momentum after collision. m1 u1 plus m2 u2 is equal to m1 plus m2 into v. This v with which the trucks move after collision is what you need to find. So directly formula substitution only, you will get the answer as 10 meter per second. Okay, check it out.